This is Jay Bowden, software manager here at Titan, creating a small video here on some of the maintenance features of our cabinet and electrical test software, along with how to create and edit specifications, recipes, test steps, those sort of things. I had in an earlier video gone over the operator interface and how it works for them. And now I'll go over some of the maintenance features for setting it up. One of the options that we have in the background, setup screens, is what we call our service program. Service program gives you the ability to look at the low-level data acquisition. So inputs, push buttons, those sort of things. Digital outputs, you can turn on and off outputs. Analog inputs, you can read analog data. So you can see I'm slowly changing the value there on my pot. You can see the analog value changing. For an output, I can double click it or hit F5 to turn it on and off. Push buttons, this is a digital input where you can see I'm simulating pushing the button on and off. So at this level you can simulate and test and try out all your hardware without needing the whole test application running. This does run in the background, so at any time during testing, if you need to break away as an administrator or maintenance department, you could come over here and also troubleshoot at the lower level. This does have a few options up here for loading, saving this configuration. You can create new channels in here, create copies of channels, delete them. So what we call channels are any of these little individual I/O items. We also have calibration screens in here, so any analog signals, so my pot switch is really my only analog channel right now. I can pick that and then I can go through a 2-point calibration, see my new values. I can manually adjust them if I want. I can reset the 0, and then if I made any changes I can do a save here. So we do kind of have a step-by-step 1, 2, 3, 4 steps here to bring up and calibrate any of the channels. If there was more analog inputs, this list would have more items put in here. We also do give you the ability to have a multi-point calibration screen, and in this case I don't have any channels that have multi-point calibration enabled on them, but this will allow you to create a table of calibration values where you have your real-world value tied to a current voltage, a current input, and you can map that out in case it's a nonlinear transducer. So this could be a table of 5 points, 2 points, 50 points if you'd like. You can insert, copy, delete rows, reset zeros, but then you can also see your live values as you're calibrating it to see how your calibration is taking effect. We're also, depending on how this is configured, if you have like a feedback tag, you could record values as you go, so you can compare one transducer to another to allow for calibration, simplified calibration. If it's an output, we can have multi-point calibrations for analog outputs. In those cases, you apply voltages there and you can calibrate it. And again, the save button will be available once you've made changes. Every channel has many different properties to go with it too. So this property box over here, you'll be able to see your calibration data. With the pot switch, you can see your cal offset scaling, those sort of things, along with where it's connected, what pins, what cab connector pin number, a bundle of different stuff that you can go in here and create and change and edit that I/O channel. As you go and add new ones, you'd have to remap them out to be the new hardware, physical hardware pin, but it's pretty easy to do. We do it through here, and then also all this data is stored in an Excel spreadsheet. So if you didn't want to go and edit and add new channels here, this is the same menu as up here, you could actually do it through the Excel spreadsheet that this saves to. Some of these are just for software testing, speed checks. You can move the channels up and down in the list and everything like that. Also have a graph utility that allow you to graph any individual input, run start and stop, and you'll be able to see any of them changing values. So here's my pot switch. As I'm changing it, you can see it coming up here. So this also allows you to add, remove channels to the line. You can save this data to CSV or image, mostly for troubleshooting, those sort of things, and then some help information. That's the service program, and that always is running in the background. Minimize it. The other item that we have running in the background, that's not running right now, is our bus monitor, and I had showed that in the other video where we're able to go through and create CAN channels and links to CAN messages and everything. Let me run through some of this. Run a single test in the main operator interface. So you can see here my bus monitor automatically loaded in the background, and the bus monitors allows us to see all the CAN data coming in and out from our CAN devices. So you can see right here I've only really have one device on my bus. It's a switch panel. You can see in the picture in the background, and as I hit buttons you can see the values change. So if it's right here, you see as I hit the buttons things change, and we can troubleshoot CAN messages. So if you don't see anything on the bus or anything like that, you can come back in here and see what data is actually being recorded or transmitted. You can send new data, you can send new messages, you can change your display formatting, reset all the data. Then I'll just clear this out. You can load a configuration of transmitted messages. You can do some filtering on the data that's in here, so you can filter by header, device type, those kind of things. You can also use this to log data on and off, to log to a CSV or a text-based file to later process or send to us for troubleshooting and helping out there. We do have some CAN tools here for DMA type of things, KWP messaging, a few of those things, so that you can simulate testing some of those more in-depth types of messages. This whole software package runs right off the C drive. We have basically one folder. You can see here's the trainer I had set up for this demo, right off the C drive. So if I go in here, you're really just in this folder. So all of our software resides in here. There'll be some drivers for the National Instruments hardware that we tend to use, or some of the other maybe serial devices. But for the most part, everything's in here. So if you backed up this folder, you pretty much backed up all our software. And so the same with if you need to send it to us, if we need to give you a new version, we can pretty much zip up the whole folder, send it down to you, back up this folder, and you put in our new one. The main test application gets compiled right here. So in that folder is test.exe, and this is the same shortcut I can put on the desktop. And that exe is what runs the main operator interface back here, along with a bunch of supporting DLLs and stuff for like National Instruments drivers, a few other things. In here we have our CAL folder. And the CAL folder is what stores all the spreadsheet that holds all of the channels that were defined in the service program that I showed earlier. There is the manual folder that has manuals in there for the software. Source code folder. This actually contains all of the .NET software. So the whole engine that loads in the background here and is running, you get all the source code. So all that code is stored in here. A lot of files in here, a lot of data in here. Most customers don't change that very often. It's kind of the base engine, but it is all there. So if you wish to have a developer down the road that's on site, he'd be able to go ahead and make changes, he or she, to how the functionality works, how the display looks, those kind of things, or even just fix it to get it to the latest version of Windows or things like that. You can do that in here. Specs folder, I'll come back to this one, but this one holds our main specification spreadsheet and our recipes and models, options, settings like that. I'll come back to that folder in a little bit. And then the support folders. So you can see the support folder is for holding supporting files. So icons, indicators, gauges, those types of things. These are just copy graphics in here. If it was a DWG for AutoCAD drawing or a PDF type of file, you could put them in here. And as long as you link to them properly in our specifications, you can show any of those pictures you want, or just replace them with the ones. And those are the ones that actually show up in this operator screen right here. That will be the end of this video showing the folder layout. I will start another shorter video going over the specifications and the test spreadsheet.